Thank you for coming to the YouTube channel, Mr. Professor, or 교수 아재 in Korean. In this video, we're going to talk about coefficient of a generating function. So please look at the problem. So we want to show that this equality holds. So by looking at the right-hand side, you can easily see this is the coefficient of x to the m in the binomial expansion, 1 plus x to the n. So you may also think of the left-hand side as the coefficient of x to the m in something, but which is equal to also 1 plus x to the n. So we probably want to know the expression of this something, which is equal to 1 plus x to the n. So how can we determine this part? Maybe by plugging the numbers, maybe into k, we may guess what this something is. Okay, when k is equal to 0, so you can see this part is just equal to 1. Okay, and from here, you can have m plus m minus 2k, that's 0. So m minus 1 and m minus 1. So we think that this is the coefficient to x to the m in something. So, well, so this is the coefficient x to the m actually in a 1 over 1 minus x to the n here. So when k is equal to 1, okay, and you can have a minus minus 1 to the 1, and that's n to the 1. And the second one is m plus m minus 2 minus 1 and m minus 1 in here. Well, so this is kind of the coefficient of x to the m minus 2 in 1 over 1 minus x to the n. So from here, we probably want to make x squared. So putting together, you can make the coefficient of x to the n. So probably this kind of contributes 1 minus probably x squared, but the n to the 1 is kind of the coefficient of the binomial expansion, 1 plus x to the n. But we have a minus n here, and as I told you, this kind of contributes the maybe x to the 2, so that the putting together, we have x to the n. So this looks like this maybe. So the coefficient of x is x squared in here. Okay. So we probably guess this something looks like 1 minus x squared to the n and 1 over 1 minus x to the n. And now you can check this is equal to also 1 minus x 1 plus x to the n. Well, actually, this is 1 minus x and 1 plus x to the n in here and in here, and 1 minus x to the n. So by canceling this one, actually this is also equal to exactly 1 plus x to the n. Yes, yes. So this part, I mean, the left-hand side, actually the coefficient of this coefficient of x to the m in this function. So actually you can see this one as the product of two functions. Okay, so from here, if you think about the x to the 0, which means that the k is equal to 0 case. So that's x to 0. And from here, so you want to choose the coefficient of x to the m, and here. And if you choose here x squared, which means that k is equal to 1 case. Okay, so that's the coefficient minus 1 times n choose 1. So because you chose x squared in here, so you want to choose from here x to the n minus 2 in here. And then if you choose x to the fourth in here, which means that the minus 1 squared and n choose 2. And then from here, you want to choose x to the n minus 4. Okay, that's n plus n minus 4 minus 1 n minus 1. So you can keep going until actually k is equal to m over 2. So that's why this equality holds. So the left-hand side, actually calculate the coefficient of x to the m in this function, okay, the product of those two. And the right-hand side is the coefficient of x to the m in this binomial expansion. And you can see those two are equal. That's why we can have this equality. Thank you for watching.